Hello, this is Sam at Forum Labs, and in this video I want to show the Fuse 1 and selective laser sintering of nylon powder, the post-processing, the workflow, and also some dental applications. There's a couple applications I want to show here today. One, and probably the most primary today, will be large production of orthodontic aligners using thermoforming and printing models. And then also just more of a fun object here, a skull, but it has articulating elements and fixturing that are built into the design. And one of the really nice things about the Fuse 1 and this platform is the build volume, how many parts you can fit, and there's no supporting structure needed, and you can print these types of articulating objects together in one part, which means that you don't have to do any assembly or anything like that with the correct design tolerances. And the Fuse 1, the way this works is the nylon powder is actually raked across the build volume, layer by layer at 110 microns, and a laser is used to solidify that nylon powder into an end-use part. And the process to post-process these parts is taking this container of nylon that's been stacked up and is now contained in the build volume, is brought over into our sift unit, and that's what you're seeing here. And really fundamentally what the sift unit is doing is it's able to eject the entire volume of the print, the powder, and the parts, and you're able to reclaim unused powder and reuse it, and also start the process of freeing the parts you're printing from the nylon dust or powder. And so you can see here we're dragging over, it's almost like an archaeological dig, where we're dragging over the container of parts and separating them out and letting the excess nylon sift through the bottom of the unit here. It is really important to note here that these are really, there's no UV curing, there's no post-processing to get final materials performance. So these are really coming out of the printer as durable and as hard as really end-use nylon products. So you can be pretty rough in how you're handling them using a pretty stiff plastic bristled brush here, as you can see, to get all that excess nylon out and start to get this to be a part that can be used or shown or handled for the general population. And so here we're doing the arch for thermoforming. Just again, a really quick brush, get out into all those crevices and get the loose nylon out. And you'll notice that the models are printed hollow. We found through testing that the orthodontic models, just in accuracy and materials usage and performance, actually did best with a thickness of about 3.5 millimeters on the hollow walls. And so you can see here after this first step of post-processing, the models are relatively free of that excess nylon powder, and then you're ready to bring them into the next step of the process, which is sandblasting. You can also post-process these nylon parts by using something called vapor smoothing, which is really a fascinating way to make smooth nylon parts out of these objects. And then also you can use tumbling, so using a automatic tumbling system to remove excess material or even give polish to these parts. But as you can see here, we have a very large industrial sandblaster with a very large nozzle, but we are roughly just taking off that surface layer, dislodging any loose material that might be stuck there. And this process is really quite simple. An arch only takes about 10, maybe 15 seconds, so it's very, very quick. And again, you can handle them roughly. They are very robust. The materials performance on these nylon parts is very, very good. So you can see here the parts coming out of sandblasting, they have a little bit of powder, a little bit of dust on them. So the last step here is to just use some compressed air to do a final air blow. And you can see these are now ready to go at this point. There's no additional work needed. And something that else is really nice about nylon powder in this process is per part cost is very low. So this arch costs about $2 or less to print after reclaiming the nylon powder, which is very economic compared to some SLA options. And we also did a lot of thermoforming testing and validation where we use a process where we thermoform over the 3D printed parts, and we have a metal master model we fit the appliance back to. So sort of replicate what a patient would find in their mouth, or a doctor or orthodontist. And the accuracy in not just physical fitment and applications testing, but in 3D scan analysis was very, very good off this platform, the Fuse 1, using SLS, and yielded some really great results. And this skull really shows how you can design fully articulated objects without having any supports or any impingement on those articulating elements. And I think what this sort of alludes to in dental technology is the ability to make sleep appliances, sleep apnea, advanced TMJ devices with these types of articulating elements all built in and 3D printed together, and not have any like support removal, making sure your parts are moving freely. I think it's going to add a lot of consistency to those types of devices, and we have a lot more to come, and I think it's a really fascinating and amazing technology for dental technology in the future. And the Fuse 1 really brings the equipment costs, also how hard some industrial versions of this printer can be, down to a level that we can see this making sense for a lot of dental businesses in the future. I hope this video has been helpful. This has been Sam at Formlabs. Thanks for watching. Have a great day.